As we know, global and local size can be 1D, 2D, and 3D, according to the dimensionality of the problem to process. For the sake of simplicity so far, let us now focus on the one-dimensional case. Let us consider this simple example. Here, both global and local size are one-dimensional, and we specify the total of 10 work items and a workgroup size of 1 work item. This means that our kernel works on one element at a time. It is mandatory that the global size can be divided by the local size. To start the execution of the n-dimensional kernel, the host has to execute the clnq and the arrange kernel function. To better understand what is happening, let us have a look to the proposed diagram. First of all, we can see our host that communicates with the OpenCL device. On the OpenCL device, we have one compute unit which contains one processing element. This architecture reflects the parameter of the global and local size. Now, each workgroup is physically mapped to a compute unit, while each work item is physically mapped to a processing element. It is important to remember that we specified a total of 10 work items and a workgroup size of 1 work item. This implies that our kernel works on one element at a time. As a result, the OpenCL device processes one input element at a time. And this is exactly the scenario that also this diagram is showing, one input at a time. Now, what if we are going to change the local size? Right now, the local size is set to 1. And this is done by storing this value in the first allocation of local. If we assign 2 work items per workgroup, this will imply that the compute unit is now containing 2 processing elements. By doing this, we are going to be able to process 2 elements at a time instead of 1, and this will obviously improve our performance, as it can be easily seen also from this figure. Finally, we could double the level of parallelism by instantiating 2 compute units, each one containing 2 processing elements. By doing this, the 2 compute units will work in parallel on different work items and process the input elements in half of the time. Let us now move from the one-dimensional to the two-dimensional case. Within this case, now both the global and local size are two-dimensional. This is done by simply setting to 2 the dimension of both local and global. This time, we want to instantiate a 10 × 10 work items and a workgroup size of 2 × 2 work items. This is done by storing the proper size in the corresponding dimension. In our example, we can see that 10 is stored in both dimensions 0 and 1 of the global variable, and 2 in both 0 and 1 for the local variable. As in the one-dimensional case, to start the execution of the kernel, the host has to execute the clnq and the arrange kernel function. As a result, the compute unit of the OpenCL device will contain 4 processing elements, which will process in parallel 4 input elements, and this is extremely improving our performances.